Hi guys, so I'm getting some questions from 7 2 point homework question number 7. So I want to go over that really quick. So something that you need to remember from geometry to be able to do this well is called alternate interior angles. So alternate interior angles, right? And basically what happens is if I have two lines that are parallel, if these two lines are parallel, and there's a line that intersects them both, right? That's called a transversal line. That alternate interior angles are going to be equal, right? So in other words, this angle is going to be equal to this angle, and then this angle is going to be equal to this angle, right? So alternate interior angles are equal, right? So that's just from geometry. So let me see if I can help you with this. So I'm going to use this ruler to try to draw this pretty accurately. So the first thing I want to do is I would recommend just drawing like an XY axis. Right? And I want the origin, that's going to be my starting point for the plane, right? So this point here is my starting point, and then I can just draw in. So using this information here, I can just draw this in. So this is, going to be north at 0 degrees. This is east, which is 90 degrees. Here's south, which is 180 degrees. Here's west, which would be 270 degrees. Right? So I got that all labeled. And then a plane, let's see, the first leg of the trip, the plane travels a distance d in the direction of 85 degrees. Right, so I'm going to tilt this. I'm actually going to tilt this about, well, let me try to draw this accurately, but it might be hard to tell with the 5 degrees. It's not a lot of tilt there. Right? Let me draw this a different color. Right? So there's my first part for the plane, and this is d miles. Right? So just to label it, what we know is that this part is 5 degrees, and this part is 85 degrees. Right? And then the second leg of the trip, we're going direction of 200. So let me just draw in like another set of axes here for this point. Right, so if we're going 200 degrees, that's going to be, let's see. So we would want this to be at 70, right? So So there's the next part, right? Because this is, going at 200 degrees. So what I know is this distance here, this angle measurement between that line and this, is going to be 20 degrees, right? Because, there'd be 20 degrees past 180, right? And then, so there's the second point that my, whoops, let me draw that back in blue. So there's the second point where my plane stops. In that, let's see, we went 175 miles. Right. So then let me connect these two. right? So then we're at 214 miles from the starting point, so this would be 214 miles this side, right? So now what we want to figure out is we need to figure out at least one of the angles of the triangle, right? So, you know, this x-axis here and this x-axis here, these are parallel. And this side here, that's d miles, that's kind of like my transversal. So what I know is that this distance here is 5 degrees, right? And this part is 20 degrees as I filled in, right? This part here. So then, you know, this part is going to have to be 90 minus 20 degrees minus 5 degrees, right? Because that makes a right angle. So that comes out to be, what, 65 degrees, right? So I know one of the angles of the triangle now, right? So, but really what I want to know in order to use the law of sines is I'd really like to know this angle here. So maybe we call this, I don't know, I guess we could call it capital D, since this is d miles, right, for d for distance. Right? So I mean, one thing that sticks out to me is that this 214 and this 65 degrees, those are, you know, across from each other, so we're going to have to use those in the law of sines, right? But I need to figure out this angle measurement D in order to use the law of sines to figure out the little d, right? However, if I know this angle, maybe we'll call this angle A. If I can find angle A, then angle D is going to be equal to, 180 degrees minus A minus 65 degrees, right? Because the sum of all the angles in the triangle should be 180 degrees, right? So that's another thing I'm thinking about. So what I can do is use the law of sines to, let me just get rid of this ruler now, I don't need it. Use the law of sines in order to find A, right? So kind of my line of thinking is I'm going to use the law of sines to find A, right? So that's kind of my first step I need to do now. The second step is I'm going to find D, right, by taking 180 degrees minus A minus 65 degrees. And then the next thing I want to do is find D using the law of sines again. Right? So that's what I'm going to do. Right? So let's do the first part first. Right? So I could take, let's see, take sine of 65 degrees divided by 214 miles, right, equals, and then let's do sine of A divided by 175, right? So then sine of A is going to be equal to 175 times sine of 65 degrees, all divided by 214. Right? So this comes out to be approximately, and let me use my calculator. Oops. Hang on here. Let me try to use my mouse. Try and just pull this off to the side. There. So we want to take 175 times, oh, let me check my mode. So we're in degrees, so good. So 175 times sine of 65 divided by 214, right? So I'm getting roughly this value. So it's positive, right? So sine's positive in the first, all students take calculus. It's going to be positive in the first and the second quadrant. So if I do second sine of that answer, right, I get that this is 47.83 degrees roughly. So this part is also going to be that same reference angle, 47.83 degrees. So if I take 180 minus that answer, well, and actually let me store this first. So let me store this answer as, oops. Your second answer. Store this as alpha A. Right? So if I take 180 minus A, then, this angle here would be 132.17 degrees. Right? But we know one of the measurements is 65, right? One of the triangle measurements. So this angle is not possible for the triangle, right? Because if I take 132, plus 65, I get bigger than 180. So that's not possible in a triangle. So the only possibility for A, so A is going to be approximately equal to 47.83 degrees, right? So then to find D, right? So we would take 180 minus 65 minus alpha A. That's going to be equal to D. So I'm going to store this as alpha D. Right? So D is approximately 67.17 degrees. Right? And I want to try to be as exact as possible. Right? That's why I'm going to store it as D. So then I can apply law of sines again. That sine of 67.17 degrees divided by little d is equal to sine of 65 degrees divided by 214, right? So then d is going to be equal to 214 times sine of 67.17 degrees divided by sine of 65 degrees, right? And again, when I reference this part, this 67.17 degrees, I stored that as d, right? So that way I can get a more exact answer. So if I take 214 times the sine of alpha d and divide that by sine of 65, then I get little d. So little d is approximately, and I think we're rounding to the nearest tenth, so 217.6, and that would be miles. Right? So if I come up here, we get D as my answer. Right? All right, so hopefully that's helpful for you to help figure that out. As always, just let me know if you have questions. I'll be happy to help. Thanks.